Hello class, I'm going to talk about cubics and quartics and quintic functions now, and talking about their end behavior and the leading coefficient. Okay, so a cubic function, I know this is a repeat of the last bit of the last video, but that's okay. We've got a cubic function, the highest exponent is 3, so it's a degree 3 function. The most simple one is this guy. Get these grids on here. Most simple one will be this guy, and that's if the leading coefficient is positive. Okay, so it starts, it's an increasing function, increasing, and it's as it approaches, we can talk about the end behaviors. Let's talk about the end behaviors. As this graph approaches negative infinity on the x-axis, it also approaches negative infinity on the y-axis. So we'll talk about that. As this graph approaches infinity on the x-axis, the y also approaches infinity. Whereas if the leading coefficient is negative for a cubic function, the opposite will be true. There's our function. And as we approach negative infinity, we approach for x, as x approaches negative infinity, y approaches infinity. As x approaches infinity, y approaches negative infinity because it goes down. Okay. All right, talking about a quartic function now. The highest exponent is 4, so that's degree 4. Now that's an even function. Okay, so we talked briefly last video about the fact that even functions start and end the same way, either up, or both down. And if that leading coefficient is positive, then they're both going to start and end up. They're going to start and end up. Now this kind of looks a little bit like a quadratic, and the most simple, x to the power of 4, looks a fair amount like that, but it's possible that this could have more curves in it. Some quartic functions even look like this, like a W, or they might have the little W doesn't have to be even on both sides, just depending on what all of these other values are in the function itself. Okay, but the most simple one is something like this. Okay. If that leading coefficient is negative instead, then we're going to start from down and end from down as well. Okay, so as x approaches infinity here, as x approaches negative infinity, y approaches infinity. As x approaches infinity, y also approaches infinity. Whereas over here, as x approaches negative infinity, y approaches negative infinity. As x approaches infinity, y approaches negative infinity. Okay, so both up or both down. All right, let's look at the quintic function. The highest exponent is 5. So you probably guessed the pattern that is happening here. We have 2 grids. The power of 5 is an odd power. So these functions are going to either start down and end up, or start up and end down. And if the leading coefficient is positive, then we're going to start down and end up. And again, this looks quite a bit like a cubic the way I've drawn it now, the most simple one. But as these numbers get added into here, if b is not 0, c is not 0, and so on, they're going to create different situations, and we could have a couple curves in here as well. Okay, but we're just dealing with some simple ones to give you the idea of end behavior and leading coefficients. So here we have, as x approaches negative infinity, y also approaches negative infinity. As x approaches infinity, y approaches infinity. Opposite way here, as x approaches negative infinity, y approaches infinity. As x approaches infinity, y approaches negative infinity. Okay, so you can kind of see the pattern that happens here. Then if we just chose a couple random functions, we don't know what these functions are, but we could tell two things about them based on their shape and their end behavior, okay? The shape here, they're both going down, okay? They're both ending down, beginning down and ending down as x approaches negative infinity. And this is how we write that, by the way. As x approaches negative infinity, comma, y also approaches negative infinity. Okay, as x approaches infinity, y approaches negative infinity again. Okay, so that's how we say that. This is called end behavior. End behavior. Okay, so that talks about that guy. So because of this, because approaching negative infinity on the left and then on the right, we know that this is an even function. It's going to have an even power. And because they're both going down, we know that the leading coefficient is negative. Leading coefficient is negative, okay? And we could see that up here with our quartic function, okay? So this is another example of a quartic function. We can see here that sometimes quartic functions will have turning points, okay? Here's a turning point, turning point, turning point, also inflection points, and these turning points would be local maximum, and this would be a local minimum as well. All right, so let's focus on this next, just random example here. We can see that one end of the graph is going down, one end of the graph is going up. So therefore we know it's an odd function. It's going to have an odd power as its highest exponent. So odd function. It's starting from down on the left and up on the right. So therefore we know that's positive because it's following these trends, this x cubed trend and this x to the power of 5 trend. So this is leading coefficient is positive. Okay, so that's how we talk about even functions, odd functions, end behaviors, and leading coefficients.